This video will cover the Geometry Regents exam from June 2015, questions 14 through 20. Number 14 says point A lies on plane P. How many distinct lines passing through point A are perpendicular to plane P? So we're going to sketch this, and a plane is just a surface. It actually extends infinitely, but you can think of it as like a piece of paper or a wall or the ceiling, the floor, something that's just a flat surface. And point A actually lies on this plane. And now we're asked how many distinct lines passing through point A are perpendicular to plane P. Now if I were to think about this in 2D, 2 dimensions, we would have plane P looks like this, right? Now of course it extends backwards, whatever. But if I want to be perpendicular to it, say it's horizontal right now, if I want to be perpendicular, I have to go straight up and down. So here's my point A, I have to go straight up and down, passing through this plane. It's kind of like sticking, a pole through a piece of paper. We want to pass through a certain particular point perpendicular to plane P. Now if I try to sketch this in any other way, I come in at a diagonal. Now of course I'm passing through the paper, but this diagonal up here is not perpendicular to the plane, because it's at an angle that is not a right angle. If I try to draw it going this way, and then passing through my paper, again, it's not a right angle, it's just some angle. So here, the answer every single time you see these 4 words, point, plane, perpendicular, 3 words, not 4, point, plane, perpendicular, the answer every single time is 1. There is only one line that can be drawn that's perpendicular. Number 15 says, students made 4 statements about a circle. Student A says the coordinates of its center are 4, -3. B says the coordinates of the center are -4, 3. C says the length of the radius is 5, radical 2. D says the length of the radius is 25. If the equation of a circle is x plus 4 quantity squared plus y minus 3 quantity squared equals 50, which statements are correct? So if we think about circles, this is in that formula x minus h quantity squared plus y minus k squared equals radius squared. So first let's tackle the radius part so we can narrow it down to either C or D. If radius squared equals 50, in order to just get the radius we need to square root both sides. But as we know, the square root of 50 is not a nice number. So we're going to break it down into 2 brand new radicals. In the first radical, we want to write a perfect square that goes into 50. If you think about your perfect squares, we have numbers like 1, 4, 9, 16, 25, 36, 49, etc., etc. The way that I was getting those numbers is just taking 1 times 1 to give me 1. 2 times 2 gives me 4. 3 times 3 gives me 9. 4 times 4 gives me 16, so on and so forth. So I'm looking through my list and I'm trying to figure out which is the largest number that goes into 50. 49 obviously does not divide nicely into 50. Neither does 36, but 25 does. 25 times 2 actually gives me 50, which means that the radius is equal to, square root 25 turns into 5, and then square root 2 just has to get carried down. So student C is correct with the statement, which means that we can eliminate choice 4 and choice 2. Now, in order to find the center, what we need to do is think, okay, negative h is equal to positive 4. Negative h equals positive 4. So I want positive h. If negative h is positive 4, then positive h is negative 4. Or in other words, just switch the sign when you pull it outside of those parentheses. So this negative 3 here is now going to become positive 3. So we have the center at negative 4, 3, which means that we have choice B. So B and C are the true statements, meaning choice 3 is correct. Number 16 says points A, B, C, and D are located on circle O, forming a trapezoid, ABCD, with AB parallel to DC. Which statement must be true? So I'm going to sketch this. Remember, if you are not given a picture, you need to absolutely draw it. So here I'm just going to sketch this trapezoid We have A, B, which is parallel to C, D. Which statement must be true? Now, if you have parallel lines, they must intercept congruent arcs, meaning AD must be congruent to BC, the arc itself, which is choice 2. And the way that we can think about this is if we were to measure the distance between parallel lines, say this is 4. If I move over on those parallel lines, the distance would still be 4. So we can think of that in the same way. The curved portion of a circle would be congruent between those two arcs, or between those two chords, rather. Number 17 says if triangle ABC is, and then there's a squiggly line, that just means similar to triangle LMN, which statement is not always true? So we're looking for false. When we have similar triangles, we know two things, two properties. They have congruent corresponding angles. Congruent corresponding angles. And their corresponding sides are in proportion. We also know that corresponding perimeters are in proportion. I'm going to say in the same proportion as sides. The areas are also in proportion, but it's the squared proportion. Areas in proportion of scale factor squared. Scale factor squared. So here I'm just going to think about choice 1 and 2 real quick because I see that it's dealing with angles. So I want to make sure that the angles are corresponding because of course I know that they're equal, they're congruent, but I want to make sure that they're corresponding, they match up with one another. So it looks like A is always supposed to map onto L. Well, that's obviously not true right here, so I think that this could be our choice, but let's go through all the other options. B is always supposed to match up with M, which is true in choice 2. So that's not our choice because remember we're looking for false, or not always true. The next one, choice 3, says area of ABC over the area of LMN is equal to AC over LN. Both of those are squared. Now AC, it is true that AC is supposed to match up with LN. And if you square them, remember that's kind of like scale factor squared. Scale factor squared. Then the areas would be in that same proportion. So this is true. And then the last one, number 4, says perimeter of ABC over perimeter of LMN is supposed to be equal to AB over LM. AB does in fact match up with LM, and the perimeters are in the same exact proportion, the same ratio as the sides. So choice 4 is not our choice, leading us back to choice 1. So the answers for this page are the following. We have number 14 is 1, 15 is 3, 16 is 2, 17 is 1. Number 18 says the equations representing lines K, M, and N are given below. Which statement is true? So it looks like the statements are trying to figure out whether lines are parallel or perpendicular. If we have parallel, then they have the same slope. If we have perpendicular, then they have opposite reciprocal slopes. So what we need to do is get each equation into y equals. So I'm going to start with the K equation. 3y plus 6 equals 2x. And to get it into y equals, I'm going to start by subtracting 6. So we have 3y equals 2x minus 6. Divide each part by 3. So we have y equals 2 over 3x minus 2. Now this is the K equation. So I'm going to box this in because I want to make sure I am able to refer back to it. For M, we have 3y plus 2x plus 6 equals 0. So we're going to subtract 2x, subtract 6 from both sides. I just don't have the space to write it here. So we have 3y equals negative 2x minus 6. Divide each part again by 3. So for our m equation, we have y equals negative 2/3 x minus 2. We have one more, the n equation, 2y equals 3 over 2 x plus 6. Oops, I was doing some math while I copied that down on accident. Just kidding. 2y equals 3x plus 6. So I'm going to divide by 2. This is where I came up with that 3 over 2. We have y equals 3 over 2x plus 3. And this is our n equation. So if I look at the slopes of these equations, we have positive 2 over 3, negative 2 over 3, and positive 3 over 2. None of them are the same, so I can eliminate choice 1 and choice 2. But if I look at these slopes right here for m and n, we had negative 2 over 3 and positive 3 over 2. Those are opposite reciprocals because they are flipped and negated, which means that lines m and n are perpendicular. Choice 4. Number 19 says a regular polygon with an exterior angle of 40 is a blank. So if the exterior angle is 40, that means it's the outside angle. And we have a nice easy formula for that. 360 over n will give you the angle on the outside, the exterior angle. And so what we're going to do is plug in here. We have 40 equals 360 divided by n. Or in other words, 40 over 1 equals 360 divided by n. We can cross multiply to solve, so we have 40n equals 360. Divide by 40, and you get n equals 9. Now, this n means the number of sides, but we have to go back through our choices to figure out which one has 9 sides. Pentagon always has 5, hexagon has 6, nonagon has 9, decagon has 10. So we're left with choice 3. Number 20 says, in triangle ABC shown below, L is the midpoint of BC. So I'm going to mark this up as we go. M is the midpoint of AB. And N is the midpoint of AC. Which then tells us that MN, LN, and LM are all mid-segments. And mid-segments have a special formula. Mid-segment over 1 equals base over 2. In other words, the mid-segment is half of its base. So here we're going to label more information. MN is 8, ML is 5, and NL is 6. Find the perimeter of trapezoid BMNC. So I'm going to take a second to highlight that in red. BMNC. And then I'm going to just close it up so we get a nice trapezoid. So we already have one piece of it, the 8 here. But we also need to find the other pieces. MN is parallel to this base down here, which means that this whole entire base is twice the length of MN. Because we can think about this mid-segment over 1 equals base over 2. If I want to get the base, I got to multiply by 2. So here we have a 16. We still have the 8, but I still need these left and right sides. If we know that the base or the mid-segment here is 6, then this whole length is 12. But 12 gets split up by M. M is a midpoint, which means that this piece must be 6. We could do something similar on the right-hand side. If this base here, I keep calling it base, I mean mid-segment. If the mid-segment is 5, then the base must be double that, in other words 10. But that gets split up into 5 and 5. So bringing us back to our beautiful trapezoid that now we've got so covered, we have a trapezoid in which we have 6, 8, 5, and 16. In order to find the perimeter, all we need to do is simply add those 4 numbers up. So we have 6 plus 8 plus 5 plus 16, which gives us a total of 35. Choice 4. So the answers for this page are the following. We have number 18 is choice 4, 19 is choice 3, 20 is choice 4.